Different analytical models and abstracting sense for organization. What are different analytical models? Majority of raw data, particularly big data, doesn't offer a lot of value in its unprocessed state. Of course, by applying the right set of tools, we can pull powerful insights from this stockpile of bits. With data in hand, we can begin doing analytics. But where do we begin? And which type of analytics is most appropriate for our big data environment? We have descriptive, predictive, and prescriptive analytical differ, and how they provide value to the organization we'll be discussing in the later slides. Descriptive analytics, which says insight into the past. Descriptive analysis or statistics does exactly what the name implies. They describe or summarize the raw data and make it something that is interpretable by humans. They are analytics that describe the past. The past refers to any point of the time that an event has occurred, whether it is a 1 minute ago or a 1 year ago. Descriptive analytics are useful because they allow us to learn from the past behavior and understand how they might influence the future outcomes. Descriptive statistics are useful to show things like total stock in the inventory, average dollars spent per customer, and year-over-year change in the sales. Common example of descriptive analytics are reports that provide historical insights regarding the company's production, financials, operations, sales, finance, inventory, and customer. It has been estimated that more than 80% of the business analytics are descriptive. Some social data could conclude the number of posts, fan, followers, page views, etc. It would appear to be an endless list if tried to list them all. Data analytics classification. Data analytics can be further classified into the three main areas that answer certain kind of questions: standard, reporting, and dashboard; ad hoc reporting, analysis, query, and drill down. Descriptive analytics are the most commonly used and most well understood type of analytics. Descriptive analytics categorizes, characterizes, consolidates, and classifies the data. Descriptive analytics includes dashboards, reports, and various other types of queries. Tools for descriptive analytics may provide mechanism for interfering to enterprise data sources. They typically include report generation, distribution capability, and data visualization facilities. Descriptive analytic techniques are most commonly applied to the structured data, although there has been numerous efforts to extend their reach to unstructured data, often through the certain creation of structured metadata and indices. Descriptive analytics help provide an understanding of the past as well as of the event occurring in the real time. Moving on to the another analytics, that is predictive analytics, which helps us to understand the future. Predictive analytics has its root in the ability to predict what might happen. These analytics are about understanding the future. Predictive analytics provide companies with actionable insights based on the data. It provides estimates about the likelihood of a future outcome. Predictive analytics is the next step in the data reduction. It utilizes a variety of statistical, modeling, data mining, and machine learning techniques to study recent and historical data, thereby by allowing analysts to make predictions about the future. It is important to remember that no statistical algorithm can predict the future with 100% certainty. Companies use these statistics to forecast what might happen in the future. This is because the foundation of predictive analytics is based upon the probabilities. Companies use predictive statistics and analytics anytime they want to look into the future. Predictive analytics can be used throughout the organization, from forecasting the consumer behavior and purchasing pattern to identifying trends in the sales activities. They also help forecast demand for inputs from the supply chain operations and inventory. Use predictive analysis anytime you need to know something about the future or fill in the information what you do not have. Predictive analytics classification. It can be further classified into the 6 categories: data mining, pattern recognition and alerts, and multicolor simulation. Data mining, which says what data is correlated with the other data. Pattern recognition and alerts. When should I take action to correct or adjust a process or a piece of equipment? Monte Carlo simulation, what could happen? Another three classification categories of predictive analytics are forecasting, which says what if these trends continue. RCA, that is root cause analysis. Why did something happen? Predictive modeling, what will happen next if? Predictive analytics use understanding of the past to make predictions about the future. Predictive analytics is applied both in the real time to affect the operational process or in batch. Predictive analytics is applied both in the real time to affect the operational process or in batch. These predictions are made by examining data about the past, detecting patterns or relationships in this data, and then extrapolating these relationships forward in the time. For example, a particular type of insurance claim that falls into a category or pattern that has the proven troublesome in the past might be flagged for closer investigation. Predictive analytics example. Some of the examples of usage of predictive analytics in the industry are telecom. A large US-based telecom company used predictive model to identify the customer who are likely not to clear their dues and eventually get terminated in the next 6 months. They use this course to design their customer reach program like sending emails or to self-cure customers. Banking. A leading Indian bank used predictive analytics to cross-sell their loan against property to their current account and the saving account portfolio. Retail. A London-based retailer used predictive analytics to forecast their weekly sales product-wise and use that information for inventory management. Insurance. Insurance company identified the customers who are more likely to churn or not likely to pay premium after minimum locked-in period. We use the regression analysis to solve this problem. Insurance. Insurance company identify the customers who are more likely to churn or not likely to pay premium after minimum lock-in period. So these are the certain examples where predictive analytics play a significant role. Moving on to the next analytics, that is prescriptive analytics. As the name says, advise on the possible outcomes. Prescriptive analytics. The relatively new field of prescriptive analytics allow user to prescribe a number of different possible actions to and guide them towards a solution. In a nutshell, these analytics are about providing advice. Prescriptive analytics attempt to quantify the effect of future decisions in order to advise on the possible outcomes before the decisions are actually made. At their best, prescriptive analytics predicts not only what will happen, but also why it will happen, providing recommendations regarding actions that will take the advantage of predictions. These analytics go beyond descriptive and predictive analytics by recommending one or more possible course of the action. Essentially, they predict multiple futures and allow companies to access a number of possible outcomes based on their actions. Prescriptive analytics are relatively complex to administer, and most companies are not yet using them in their daily course of business. When implemented correctly, they can have a large impact of how business make decisions and on the company's bottom line. Large companies are successfully using prescriptive analytics to optimize production, scheduling, and inventory in the supply chain to make sure that they are delivering the right products at the right time and optimizing the customer experience. So what are the classification of prescriptive analytics? Prescriptive analytics, which is a part of advanced analytics, is based on the concept of optimization, which can be divided into two areas, which is optimization. How can we achieve the best outcome? Sophisticated optimization. How can we achieve the best outcome and address uncertainty in the data to make better decisions?